So good afternoon class, let's start. So this is the second part of the data link layer. Now what do we do here is, so we have discussed error detection and correction scheme. So what happens in this is sender sends D plus the error detection code. So some bits as well as the D, the original data. So these two things it will send to the receiver. Now receiver receives some D dash and EDC dash, and now note that D dash and EDC dash will be different from the original data and EDC because there can be error induced while it was transmitting from the channel. Now the receiver challenge is to determine whether D dash is the same as the original D or not. Now these EDC and EDC dash will help determining that, and this is exactly, so what it does is it uses those EDC and calculate again EDC using this D dash. It calculates EDC. Now it matches EDC and EDC dash. If it's same, then there is no error. Now there are three techniques that we are going to discuss today. First is Parity, second is Checksum, and third is CRC. Fourth is hemming code, and we are going to discuss hemming code in next class. Now first is Parity. Now what happens in Parity is, we have discussed in last class as well. So to make this even parity, what we will do is 3 4 5 6 7 8 9 9 ones are there. What we will do is we want to make it even parity. So what we will do is we will add just one over here, and so to make 10 ones. Now sender and receiver both knows that data is even parity. Now sender sends this. If any of the bit is flipped, this means the receiver will receive either 9 ones or 11 ones, right? If one bit is flipped, either 0 will be flipped to 1 or 1 will be flipped to 0. So either it will receive 9 ones or 11 ones, but because it's even parity, receiver will discard the data and say that you have to resend the frame again. It will drop that data, right? So this is parity check. Now we have also discussed two-dimensional parity in last class, so I'm going to skip that. Now let's start with the second method, which is the checksum. Now checksum is very interesting. We have already studied that in UDP we have checksum field. What happens in checksum is, suppose sender is having some data set. Suppose sender was having 1 0 and 1 1. Now before starting checksum, one funda that I want to tell you is, funda is, if you add 0 0 0 and 0 0 1 and you take one's complement of this number, which is 1 1 1 0, and now if you add these two, you will always get all ones, right? So this is a funda. Okay, this is a funda behind checksum. Okay, now so whenever you add a number as well as one's complement of that number, you will get all ones, right? Now first number was 1 0 and second number was 1 1. Okay, now what you will do, sender will do is, it will create a sum, checksum of these two things. This is the whole data set, basically datagram. Okay, so it consider 2-bit checksum, 2-bit checksum. So suppose value was 1 0 1 1. So this was the data, and if you want to create 2-bit checksum, you have 1 0 and then 1 1. So it will create a checksum. It will add this, right? Whatever it gets, suppose it gets 0 1 1, right? What it will do is, it will take one's complement of the sum 1 0 0, and it will send this to receiver. Now if receiver has 1 0 0 as well as the data 1 0 1 1, this original data, okay, so original data will also be sent over here, which is 1 0 1 1. Now what receiver will do, it will again calculate the sum of this. If sum of this is again 0 1 1 0 1 1, and receiver, what it will do is, received checksum plus checksum it has calculated, it will add these two. If it gets 1 1 1, all ones, then it will be accepted, otherwise it is rejected. So funda behind this is, it will add the two numbers, one number that is received by that is sent by the sender already. Second is it will again take the sum of the data, and it will add those two, and if you get all ones, then the sum is accepted. That means there is no error, otherwise there is error. Now there is one more catch with this is, Suppose checksum is also changed in such a way that this is the problem with this checksum, that suppose checksum is changed and the data bit is also changed, both bits are changed in such a way that sum is correct, so that can happen of course. So that is the disadvantage of this checksum. Okay, so exact same thing. So here data was 1011, so I have taken two bit values to checksum. So in 16-bit integer, generally in UDP what we do is we have suppose uh, 20 byte UDP segment. What we will do is we will take 16-bit sum of the data checksum, we will create it and write it in the UDP checksum field, and we will send the whole UDP datagram. So receiver will again calculate the sum of all the 16-bit values, and it matches it with the checksum field in the UDP header received. Now if the match is all ones, it will add those two. If it's all ones, then it is accepted, otherwise it is rejected. So that is the idea behind checksum. Now next is cyclic redundancy code. Cyclic redundancy code is very important, and a variety of errors are received by this CRC. Okay, now what happens in this is, suppose you have some data set. So I will just go to the example. So this was the data 101110. Okay, and this is the divisor. This is known by sender as well as receiver. So sender knows 1001 and receiver also knows that 1001. This is the divisor. This is some value that we use to calculate CRC. Okay, now sender and both agrees to some common value. So suppose sender and receiver has agreed to this 1001. Now what will happen is, data was this. So what you will do is you add, because this was 4-bit dividend, you add 3 zeros over here. Okay, you append it 3 zeros. So if divisor was 5-bit, you will append 4 zeros. If divisor was 6-bit, you will append 5 zeros over here. So one less number of zeros than the number of bits in the divisor you will add over here. Now what you will do is you will calculate the sum. Now very important thing is, this sum is not actual subtraction, it is actually XOR. What you will do is you will do XOR. So 1001 into 1 is 1001, right? And you will do XOR. 11 is 0, 10 is 1, 00 is again 0, and 11 is 0. So you do XOR, you do not actually subtract it. Now what you will do is you will take 1 over here, now 0 over here, so you will get 000. Now again you will use this value, download it from here, so you get 1010. Now you have 4 bits, so 1 will be value in the question. Now so you copy 1001, 1001 into 1 is 1001. Now you again take XOR. So this is 1, 10 is 1, 00 is 0, and 11 is 0. So you get 11. Similarly, you again place 0 over here, then you again drop. So you keep on doing it until you get some reminder. Now reminder is 0, 1, 1. Now what you will do is you will append 101110 with 011. So your data, this is your data 1 2 3 4 5 6 bit data plus 3-bit reminder. You will send this all to 1001. Why you will send it? Because if you add reminder to any number, suppose I divide, just a simple example, suppose I divide 5 with 21. Suppose I divide it with the 24. Okay, or a simple number, suppose this was 2 and I divide it with 19, right? Now if I divide it, what I will get as reminder is 1. Now if I add this 1 in this 19, if I add reminder in this basically dividend, if I add this, now this number will be divisible by 2, right? So we can add reminder to the original number, so now that would be divisible by the divisor, which is 2 over here, right? So what our aim is to make this number divisible by 1001. Okay, now if I divide this number by 1001, so you will get reminder 011. So what you do is you remove these 3 zeros that you have appended. Instead of them you place 011 over here, and then you send this whole data to the receiver. So example is given over here. So this was the data 100100. So 10100 as well as 001. This was the reminder 001. Okay, so this was the reminder that this is the value that is received by the receiver. Now receiver, what it will do, it will try to divide it 1101 with the same divisor. Divisor is known by sender as well as receiver, right? So sender and receiver both knows the divisor. Now guess what will happen. So what will happen is, if the reminder is 0, because you have already added the reminder and send it to receiver, now the number is divisible by this divisor. Now if number is divisible by divisor, reminder should be 0. If this reminder comes out to be 0, then that means the data is not flipped and there is no error. Okay, otherwise if this reminder is not 0, that means that your data contains error. Now a variety of errors are checked, single bit error, then you have odd number of errors and so on. So variety of errors are checked by this CRC. This is very interesting concept. So this is again one example. So you append, this was the data 1100, and you append this reminder 011 and send it to the receiver. So this is the basic code that you send to the receiver, and then you calculate it. So that's what CRC is. Now last is the Hamming code. We will discuss it in the next class.